And welcome to Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, working on this Sunday. It's getting chilly outside, so we're getting our toasty socks on. And today we're looking at prototypes. This week was a short week because of the holiday, so I ended up doing a lot of house stuff, which is good. It's good to have a nice, clean, organized house. Not as much engineering, but that's okay. I did get some prototypes in, so let's talk about those. Let's go to the overhead. First up, we got in the shop at least photos of the BQ25185 boards that we worked on a couple of weeks ago. Those boards, I have to finish the testers for them. I'm really, really close. I got delayed with the short week. But those will be in stock next week. But then I also designed a version, I think on the show like 2 weeks ago, that had a little boost converter. So this is the TPS 51023. It's a 2 amp max boost converter. It's a 3.7 amp switch, but it's like the inductor isn't really that big here. It's kind of chunky, but it's not enormous. It can do basically an amp, and the goal here was just to make something low cost and simple. It's like not the biggest. I think if I was going to make another board that could actually do like 5 volt 2 amp out of a battery, you actually need a little bit of a bigger inductor, a lot more capacitance and stuff. Pair that with the 25185, and then I've been testing it. Thankfully, it hasn't been too rainy. I've got this big solar panel I use for test. So this gigantic solar panel is max at the sunniest July direct light is like 800 milliamps. So considering that this does 1 amp max into the DC pin, this is like a great test. So I stuck this out the window. I have a really nice long cord, powered it, and I did power monitoring on it. And the solar does a really good job of stabilizing at the lowest voltage that lets it charge the battery that's plugged in. Tilting it around to get a little bit more current, but pretty much it worked quite well. So I'm really happy with the solar performance because it's not mentioned in the data sheet for the BQ25185. It's kind of like mentioned in like an app note-ish kind of sort of. It's not like an official capability, but it's something that does work, so it's kind of cool. So one thing I was thinking of doing is maybe future feathers, swapping out the MCP 73 charger chip for this chip, and thus making it a lot easier for people to do solar charging. Still not 100% sure I'm going to do that, but I'll think about it. So that's that. This design is good. One thing I did notice, if you go to the overhead, the computer, is because I was seeing a weird behavior, and it turns out I'm actually glad when I see on forums or other people have the issue. So TPS 51023, one thing it doesn't do very well is, and the thing is I'm testing it on my bench and I have my electronic load, so I'm able to draw an amp and verify can it really supply an amp, and then I measure it, I look at the voltage on the oscilloscope to make sure it's stable, and I test it with different battery voltages, and I noticed that it could definitely supply up to an amp. But if I toggled the enable disable pin, it would not come back after being disabled. And it's actually just a thing with this chip. This chip cannot enable directly into a 1 amp load. It can directly enable into 100, 200 milliamps. To be fair, 100 or 200 milliamps is quite a bit, especially for again, just the startup. So as long as you're not directly connecting this to a motor, as long as it's connecting to something that has a slow, maybe a microcontroller setup that maybe powers on, and then it turns on the Wi-Fi after a few milliseconds after it stabilizes, you're good. I don't think it's the capacitance on the output. I really think it's just the chip is just not able to stabilize itself at if you're doing this constant current load and you're enabling disabling. This is one of those engineering decisions could I find a chip that would do it? Sure. Would it be more expensive? Maybe bigger, maybe be more complicated, maybe have other downsides. I think as long as this is well documented, so people know what to expect, they're good. Again, 100, 200 milliamps is quite a lot for instant start for most things. Usually you don't, like I would just tell people like, hey, you can't connect this up to a gigantic LED array and expect that it will, if you're doing NeoPixels, maybe you would like turn the microcontroller and then turn on a couple of NeoPixels at a time instead of just like blasting them all on at once. If you're using that enable disable pin. If you're not using the enable disable pin, again, as long as it's like, on power up, I think you're good to go. So, it's not really like app notes and data sheets don't mention this stuff. You have to look, one of the things I've noticed about chips is like, you don't really know until you have it on your bench and you're actually testing different loads and switching it. Like I remember when I think I even covered it. It was like the TSC 2007, which I really like this I2C resistive touch controller, but had this like totally freakish latch up on the power supply that would occur. And so, if you're enabling and disabling it, you had to like have the power be separate, whatever. Basically, in the end, what I ended up doing was having on boards that use this chip. It doesn't matter on this because this has its own power supply. But on the boards that use this chip, I have a separate power supply just to avoid that latch up that occurs. And like they kind of mention it in like a secondary app note. It's not in the main data sheet. I don't know. It's kind of life in electronics. Okay, so let's look at some other samples. On the overhead, I've also got this sample came in, so I'm excited. Maybe I'll test this out today. This is the split boost. I love this because like I always love supporting my analog peeps. People who are doing synthesizers, analog op amps, maybe some light galvo control motor stuff where you need positive and negative 12 volts or positive and negative 9 or 15 volts. So I'm going to test this out on my load. One thing is I don't know if I have a way to test the negative voltage load. I guess my electronic load is floating, so I would just swap and like test it as if it was positive. Negative supplies are weird. A lot of stuff doesn't like, it's like it's, a lot of electronics these days is not like negative. They're not into negative supplies. Like maybe a bias for a LCD, but if you want any significant current. But I put some chunky inductors on there. These are nice shielded inductors. These were kind of expensive, but I wanted them to be small and I wanted them to have the current capability. I think this could do about 100 milliamps or so out of 5 volts. So we'll try it out. And I think, like I said, it's like, I've never seen anything like this available that can generate from 5 volts to split supply. So I'm kind of psyched. And this came from the Flopsy board. I spec'd this part for generating the negative 12 volts for the Apple Disk 2 connector. Okay, how are we doing on time? Good. Okay, next up I got this cable. I'm kind of psyched. This cable's cool. Okay, so this cable sample, we got this from our cable supplier. And they're like, we sell a lot of their cables. So I kind of have like weird ass ideas, and they're like, yeah, sure, we'll make this weird idea for you. So this is a panel mount USB-C and HDMI, and it goes to USB-C and micro HDMI. So I thought this would be awesome for Raspberry Pi 5 and 4 computers, where you want to have a panel mount for power and video, which is like what most things you would you'd connect to a Raspberry Pi in an enclosure would be good for, and then it also like does the conversion from micro to HDMI. The only thing is I kind of wish this had the screw type instead of the like the kind that has the big nut, because that's my favorite type, rather than these screws. But that's okay. You can still drill the hole and then you panel mount this. And then I also got a version. This is a shorty version. I got a version that does just regular HDMI to HDMI. So that's kind of cool. So I'm going to test those. And I got, I remember like when we were moving, I found that ginormous box of 3.5 inch capacitive touch screens. And I was like, yay! Like I bought, I had $10,000 of screens. And I can use them. Well, we actually sold them out, and so I have to get another one. So the only thing is, when I bought, those screens were 10 years old. And to be honest, we don't even buy from that vendor anymore. So I have to get, the hardest part is actually, how am I going to get this out of this bag? How did I get it in this bag? like perfectly fits. Okay. Oh man, this cracked. It says sample cracked. I got another sample. But I can at least just test the TFT part. That's annoying. That's what I get for having my samples in my bag. But capacitive touch, and then I think the chip change. This is probably an FT Focal Tech. Yeah, it's a Focal Tech FT5, probably 336. So that changed too. Oh no, so sad. That's okay. I'll have another sample, and if not, I'll just order another one. Also, sometimes capacitive touch still works even if the glass is the protecting, because there's the protective glass and there's the actual capacitive glass. So we'll see. Maybe it'll still be okay. And then this is kind of a weird sample. Weird samples. This is something that takes 20 volts DC and provides a USB-C output. And I think it even does power delivery selection. Although I don't know how that could possibly be doing buck conversion in such a small space. Maybe it does 20 volts. I don't know. I got to test this out. This is kind of a weird thing. This is the opposite of what we normally stock, which is USB-C PD to DC output. And then finally, from Mr. Ladyada, he wanted to do like a holiday display, because now we live in Brooklyn, so we have like a yard, so we can like put things in the yard. So this is it's like a Halloween prop motor, and it's geared down intensely. So in here, there's a gearbox. There's like no documentation. This is a 24 volt motor, and then this is geared. And what's kind of cool is that this is press fit in, so you could remove this. You can see there's like a D in there with a little something inside. This could be connected to something else that it spins. So you don't have to mount. You don't have to connect directly, although this is nice soft plastic. You can totally bolt it to here, and you even get a little bit of clearance for your bolt heads, so you could bolt it directly. And then I just have like a 24 volt power supply here, and then I'll just hold this up while I touch this. And you can see. And then you can, of course, this is kind of fast. For a geared down motor, right? Remember, it's really geared down. But you can PWM it to change the speed. So he also got a speed controller, which is it's basically just like 3 MOSFETs in a trench coat. You just get your power input, your motor output, and then you can set the direction. And then this is just a PWM speed controller. It comes in a box. I don't know. It's like $20 or something. So cute design, looks fine to me. Of course, not waterproof, so this has to be indoors, but maybe we can extend the cables or something. Okay, so that's anything else you wanted me to show?
No, I wanted to try some off-the-shelf stuff for this project, and then I wanted to try some custom solutions, and then I wanted you to see it, because often there's things that are out there, and I'm like, hey, here's what I'm building, and you're like, oh.
Yeah.
Here's some ideas.
Okay, well, let's go into the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey Adafruit. Thank you, DigiKey. Every single week, Ladyada uses her powers of engineering to help you, yes, you, find things you want on digikey.com. Ladyada, what are you searching for this week?
Okay, so this week, I'm following up on last week. We showed off the RP2350 Metro design that we did, and that is working out great, getting the PCBs. And one thing I did, which I had a couple people be like, what's up with that? Is like, why did you have, so these are the capacitors for the the flash memory, right? I have like 1.1 microfarad cap here and one here for the PS RAM and the flash. And it's like, why are they over here? Don't you want to be like tucked right in next to the 3.3 volt line? And I didn't actually on purpose, because I wanted to make enough space here for an SOIC clip to grab onto. This was a request by Tan Newt, who is on leave right now. But he was like, if you're working on this, could you like please make it so I can clip on? Because when we're debugging a board, sometimes it's good to be able to see what, like, especially when it like hangs, it's good to see like what was the last thing that the RP2350 tried to do on the flash or PS RAM. Especially when you're trying to get PS RAM up and running, you're like, is the PS RAM being activated? You want to be able to look at it, make sure that the speed is correct and the commands are correct, and especially like flash memory. Sometimes you have to like when you first turn on flash memory, you have to like put it into like a mode. You want to make sure it's going into quad mode, for example, because otherwise, if you're only in dual mode, you are not getting the full bandwidth of the chip. And so I added a bunch of clearance here, both between here. You know, I tried to do my best to let it be possible to clip on a clip. And then I realized I didn't show people about SOIC clips. These are brilliant inventions. They're very handy, especially when working with flash memory on a device where you want to dump the flash off. That's really common. Remember, like a lot of times people are configuring motherboards or Wi-Fi routers or like game systems or all sorts of stuff that uses 8-pin SOIC or I2C EEPROM or flash. It's like so standard. It's so standard. And SOIC packages are the most common. You're not going to see DIP, and often people don't go for, sometimes they go for the smaller packages, but SOIC, they're so cheap, so available. Also, if you're doing single board Linux computers, sometimes you actually use like your boot partition as flash. You can flash it directly. So let's go to DigiKey. And let's look up SMT clips. This is a weird category. I was like, where would it be? But it actually turns out, I think it's its own. It's not under holders. Maybe it's under SMD clip. Oh, interesting. Okay, hold on. Let me search for SOIC clip. It's under IC clips, not SMT clips. Sorry. So this category, so what's cool is, I'm not going to get into it, but you can get like the most messed up clips, PLCC clips, they have DIP clips, lots of SOIC clips, and we'll show you the varieties. Huge DIP clips, I don't know, all sorts of like weird stuff. PLCCs are not that common anymore, but I don't know, maybe if you're working in some older industries or repair industries, these are handy. Maybe for like parallel flash memory. These are so cool. Okay, but anyways, we're looking for SOIC, which there are a couple. And they do come in wider size if you're doing octal PS RAM, but let's just look for the active and in stock items. These are looking good. And one thing I want to mention is when you're looking for, well, first off, we want 8 position. So let's just get that out of the way. One thing to watch for is SOICs come in 2 sizes. And I made this mistake in my life. I once was like, oh, I'll get the 3M one, but the 3M one is actually only good for 0.5 inch body, and that's the smaller size SOIC. Let me show, maybe I can show the feather. Or maybe I'll look at the Metro M0. No, this is the wider. This is the wider SOIC. I think maybe the feather M0 had the. Yeah. Okay. So this is the smaller SOIC. This is 0.5 inch. And then I'll zoom in so you guys can compare and contrast. And this is the wider one. And when you're looking for, oh yeah, okay. So if you're looking, yes, you see this is like, it goes a little bit wider. It's actually like 0.2, sometimes like 0.25 inches. There's actually a couple different widths. If your flash memory is 2 megabytes or below, often it will come in the smaller width. And if you're going 4 megabytes or above, or 16 megabits or below is the thinner, sometimes 16, but usually 32 megabits or above, you're going to get the wide one. Also, you'll notice I made this this SMT package can support either width. When you get your test clip, I made this mistake. Don't get the one that's narrow, that only supports 0.15. You need to get the one, the SOIC body. Make sure you get one that is type. Boop. That can do either. So let's select dash, but also dip. So there's a couple options. Daddy Prog, I've never heard of these, but these look kind of good. I like the nice grips available. Muller, these look okay. But the most common is the Pomona, which is why you'll see there's like a trillion in stock. So they do need a little bit of strength. The S3M ones need a lot of strength. You do need a little bit of, just be ready. You need to have a little bit of strength. And then, of course, you also want to connect onto here, use, socket premium connectors to get to them. And you need clearance. They don't show you here. A little bit annoying. But see, it's like when you clip on, you need space both on the side and on the front. And so if you're clicking into an existing board, like you have some Wi-Fi router or something that you're dumping the flash off of, you may need to remove any, especially if they're not essential. So if you have bypass 0.1 microfarad caps are often really nearby, you might have to remove those. Otherwise you end up crushing them, or you won't be able to get the clip on. And these little, there's these little like teeth notches. They need to get underneath the body. You think you're clipped on, but you're not until those like actually hug underneath the body and clip on. I've like debugged many times and been like, oh, I'm debugging. I think I'm debugging. It turns out like the pin isn't actually connected on. But I recommend this one. This one's good, and it's like less than $20. It's a good deal. Maybe you don't need it today, but if you're putting together a cart, add this in, because when you do need it, you're going to be really happy. I've used this to program chips, debug in circuit, program flash chips, raw on the fly. Very, very useful. And if you actually want to do the programming itself and you're like, oh, I don't want to, you have to have something, you don't want to hook up an Arduino, a bus pirate, which I think they have in stock. Yeah. So a bus pirate 3 or bus pirate 5, both of these. The bus pirate 5, I think, is the most recent. You can pick this up and it will let you use your computer to program or debug SPI flash. So pick this up from Pomona, a recommended SOIC test clip.
And that is the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Thanks for joining us today. Okay. Have a wonderful Sunday, everybody.
All right. Bye-bye, everybody. See you all throughout the week.
Stay warm.